Good afternoon, everyone, and welcome to Cullen's Gable Restraint System webinar. My name's Sam Kirkham, and I am the Cullen Category Manager within ITW's Offsite team. So today, this webinar is going to be hosted by Scott. So Scott McAndrew is our Offsite R&D Manager within the business. Scott is a well-recognised contributor to the offsite construction market, and he's got over 35 years worth of experience, and is also the creator of Cullen's Gable Restraint System. So why are we running this webinar? So through market insights collected through our offsite customer back innovation process, this revealed knowledge gaps, educational needs, and lack of materials related to Cullen's Gable Restraint System. So the webinar is the final part of our internal 6-part Gable Restraint System campaign. And our goal is to educate, engage, share expertise, and promote our NHBC-accepted, patent-pending system. So Scott's going to take you through an overview of the system. This will be covering the what, why, and how, and we'll be showcasing some of our new and existing material and resources related to the system. Following this, Calvin Pretorius, our Business Development Manager for the Paslode team, will also be giving us a short overview of the PPNXi nail gun. We'll then conclude with a Q&A session and a live draw to announce the winner of the PPN gun that Calvin and the team has kindly donated. So this draw will be done using a random name selector for the people that are attending today. So we'll do that at that point. Please ask that you hold your questions until the Q&A session. But if you're like me and you don't write something down, you tend to forget it. There is a Q&A button at the top. And if you stick your question in there, and we'll address them at the end as well. Also kindly ask that everyone puts their mics on mute, just so we could get no sort of background noise throughout the webinar. And that's it from me. I'll pass you on to Scott now, and he'll take you through the Cullen Gable Restraint System.
Hi, for anybody that doesn't know me, I'm Scott McAndrew, and for the last 21 years I've been designing bits of metalwork for our Cullen side of the business. I will try and speak slowly enough that everybody understands me, but if I do get carried away, I'm sorry. So we launched the Gable Restraint Bracket back in 2019, and I presented a webinar detailing the GRB system back in 2020. So we'll go over some of these things again. I'm also going to cover new information that we have added to the GRB documentation. A little bit of history behind timber gables. Prior to the development of the GRB system, house builders were wanting to speed up the process, reduce working at height. Timber gables were being used to do these things, but without any proper design, detailing, testing, installation, and how to properly restrain these. So these gables, without any proper detailing, could result in a collapse of the gable end. Which sounds a bit dramatic, but most of us will have seen, there's a YouTube video kicking about where the guy's walking past and the gable collapses right as he's walking past the building. That was a brick and block construction, but it's the same issue. The gable wasn't adequately restrained. NHBC highlighted problems with these timber gables and called a workshop where the NHBC, National House Builders, Taylor Wimpey and Barrett was there, trade associations, the TRA and the STA were there, and also industry experts, which included ourselves. So we got invited to this workshop. After the NHBC meeting, the TRA also held some regional workshops to go and discuss these problems. So before we started developing a solution, we needed to understand what forces are applied to the gables. So the gables are subjected to wind forces, which depend on the direction, as either a wind pressure on the wall, or as the wind comes up and over the roof, it creates a suction effect. The wind pressure, the blowing is straightforward and creates a push effect on the wall. But as it goes up and over, the suction, the pull effect, then it's creating, you've got to restrain it against that. To explain it a wee bit better, if anybody's been in a convertible, your hair doesn't get blown backwards, it gets blown forwards because it creates that suction effect going up and over on the car. I didn't hear that problem. So on traditional brick and block constructions, these wind forces are restrained and transferred into floor and roof diaphragms using restraint straps. The requirement is for these restraint straps to be provided to provide 8 kilonewtons of resistance and be installed at 2 metre centres, and that's the requirements to meet the approved document A and the Scottish building standards. As I'm talking through this, I'm going to refer to approved document A, and I won't always refer to Scottish building standards, but we are the details that we're doing is in line to meet both of them. So our system needed to provide at minimum the same level as restraint as what the traditional restraint straps provide. So what was done? After the NHBC workshop, they created a guide to spandrel panels. And after we'd launched our GRB system, the TRA created a guide as well. I also presented at the TRA AGM a few years back as well, presenting this. So this is the NHBC detail. And although this detail restrained everything, it gave additional restraint, it also created issues. It ended up introducing forces into the roof trusses, which the roof trusses weren't normally designed for. So that detail wasn't ideal. So we had to, when we went away and started designing our gable restraint system, we had to try and sort of make sure we weren't introducing forces that wasn't there, or we didn't want to have in these certain places. So we looked at the challenges that we had for this, and started working on a solution. But we had to ensure we could transfer the load, securely fix between the timber gable and the masonry, meet the requirements of the approved document A, be accepted by the NHBC. And when we started having the discussions with NHBC, they asked us to go and come up with a system approach. They didn't want us to come up just design a piece of metalwork. They wanted us to actually design a complete system that could be used. Also, this was a new way of doing gables, so we had to educate and make everyone aware. So we have revisited everything we've done, and based on technical queries and customer feedback over the past few years. So we've added additional details. We've created installation videos, and as Sam said earlier, we've had a 6-part campaign, and this webinar is the last part of the six-part campaign to raise awareness and provide further detail. So developing our system, going back to the previous slide with the big bad wolf, we had to understand in more detail what was happening with the wind loads. So this is my sketch I'd done during the development stage for me to understand where everything was going and what was happening. So half the ground floor and half the first floor goes into the floor diaphragm. Then the other half of the first floor, and then half that gable goes into the connection along at wall plate level, wall head level. So this is what we then had to go and make up our system to go and try and connect all this together. So your gable restraint system is made up of 5 parts. We've got our GRB, which is attaching the gable to the wall plate. Our VRS, that's holding down the gable against wind uplift. Our RST3 is providing the horizontal restraint against the wind suction. Our PFS is providing horizontal restraint, but going up the slope of the roof. And then we've got our timber frame wall ties, our FT wall ties, tying the block work to the gable. And that is also then transferring load that's going on that gable back on the brick or block gable back into the timber gable. So running through all these different parts, we've got specific installations to go. To meet your system, we've got specific installations we have to do. So the first part is attaching the GRB to the wall. So the GRB sits on top of the wall. There's no fixings between the wall and the GRB. It's got an overbend on it. It actually grips the block work. There's a mortar bed placed over the top of that, and then your wall plate would get bedded onto the mortar bed, and the wall plate is attached to the GRB using either a square twist nails or wood screws. This wall plate, we are recommending it's allowed to cure for 3 days before you then to actually get the embedment between the two. So one of the things on this compared to what the NHBC detail was showing is we've got a continuous wall plate all at the same level, where the NHBC detail on the gables brought the gables up an extra courses of block work. So your truss wall plate is now also the same level as your gable wall plate, right the way around the building. One of the things that we've seen since we launched the system was these being installed incorrectly. So sorry if I've used anybody's pictures that they've sent into me, but these are things that's actually come into our technical, through the technical support desk. First ones have been installed upside down. That isn't acceptable. It's got to be installed the correct way around, with the fixing part being there for going into the timber. Also, it has got to be installed on the block work, not on top of the wall plate. I've also seen that happen. Saying, is that acceptable? Nah, it's not doing anything there. Once they have been installed correctly and the wall plate's cured, the trusses are positioned on the wall plate, and then the gable is dropped into position as well. The gable panel must then be fixed to the wall plate. The critical point here is ensuring that there's a blocking piece between the gable panel and the first truss. And going back to what we were saying originally about the wind pressure, the push pressure, that blocking piece is what is transferring that wind pressure into the braced roof diaphragm. Now, we've calculated all the loads that's required to meet the approved document A, and I'll talk about this later on. So the nailing of that wall plate is critical, and it's all been calculated using a 3.1 by 75mm long Paslode nail at 175mm centres. And I'll explain why later on about the loadings. So then we've then got to attach the gable. So we're attaching the gable into the roof diaphragm using our RST3 straps. Now they are installed at 1200 centres. So it's nailed into the face of the vertical studs of the timber gable, and then attached to the bracing on the longitudinal bracing on the bottom chord of the truss, or additional bracing members that need to be put in to keep your 1200 centres. Then your VRS 900, 100 vertical holding down straps are then also fitted to hold the panel down against uplift. Same way as your wall plate's held down, we're now holding the panel down. Oh, sorry, I'm losing my voice here. So previously we looked at the traditional restraint straps at 2 metre centres. These traditional straps are built into the blockwork and are tested with equivalent to a story height of blockwork up on top of them. Now, these straps provide a minimum 8 kilonewtons at 2 metre centres. So based on that and the tested value of our GRB and RST3, we have determined the fixing spacings to provide the equivalent amount of restraint. And as we don't have that same amount of blockwork sort of sitting, well, we don't have any blockwork sitting on top of these straps, they're being attached to the vertical face of the stud and they're being nailed, then we've had to reduce the centres from the 2 metre centres to 1200 centres to provide the equivalent load. But by doing these and installing these at the centre specified, the GRBs at 1200 marks and the RST3 straps at 1200 marks, we meet the requirements, the approved document A and the Scottish Building Standards. So we've restrained the gable along the bottom, but we've still got to think about, you've got up the gables as well. And that's done using our PFS, your standard restraint strap, your PFS 1500-100 with a bend on it. And that could either be installed, as we're shown there, it could go over the top of the trusses or underneath the trusses, but it's hooking over the gable panel. So depending if you're having a gable ladder or not a gable ladder will determine which level you're going to install that at. Same thing, just a different picture, showing the straps over and under, going up the slope of the roof. Now, on a previous GRB information, we didn't detail the wall ties. And it's a question that's been raised, and we've been asked about this through our technical support the team. So this has now been added to show the wall ties. The position shown in here is to meet the requirement of the NHBC. Somebody's dying. So the red and green positions shown on here are the additional wall ties that's required along the bottom and going up the top. So when it's near the bottom of the panel, we've got to put additional wall ties in, and it's as you go up the top, you're putting additional wall ties in. The blue wall ties in the centre, I've shown them at 450 centres here, but it's up to the building designer to specify them depending on where this is being erected. So it could be 450, it could be 225. You could go belt and braces, put them all in at 225. We'll sell more wall ties, but it's really the responsibility of the building designer to go and specify this. So from our customer feedback, we have seen that due to changes in the thermal requirements, the cavity in brick and block construction is increasing to allow thicker insulation. And we will shortly be introducing a new wall tie to suit 125 to 150 mil wide cavities for connecting the timber gables to the masonry. Hopefully we are future-proofing ourselves to also meet the requirements of future home standards as well. This is the detail showing everything. Everything we've just shown and went through is all on one detail here. But going back to the earlier slide when we were talking about the loads, the way our gable restraint system works is the gable restraint system is the gable restraint bracket is taking the load from the wall and taken into the wall plate, which is then attached to the gable panel. So the GRB is transferring half the wind load for that top half of the floor. When we had the sketch showing the floor where the loads were going, going to the floor diaphragm, so they're going up above. It's only that top half of that wall, the gable restraint bracket, is transferring into into the gable panel, and that's all our nail fixings actually doing as well. But then our RST3 strap is then transferring the load from the gable panel into the roof diaphragm, and this is taking the full top half of the panel and the gable as well. So your GRB is actually working. When we talk about the restraint straps providing 8 kilonewtons at 2 metre centres, the GRB is transferring 4 kilonewtons at 2 metre centres. But your RST3 strap is transferring that full 8 kilonewtons at 2 metre centres, equivalent to that. Everything's worked on the equivalent basis of that. Same construction detail, just face on. So everything I've just said applies to that as well. This is something that's come up recently. We've been getting asked a few more questions regarding this for openings and cavity trays, and these clashing with the position of the gable restraint bracket. So we've done some work on it. We've now got these additional details. So when you've got these openings, all we're doing is you'd still have basically what would be your spacing all the way along, but the ones that's then clashing, we're moving either side of the openings. And as long as that opening doesn't exceed 2.4 metres, then if you follow this detail, you're providing the same amount of restraint as you would if these were positioned all the way along. One of the other things that we've been asked about is jointing the panels, because not everybody's going to make these gable panels in a oneer. You're going to either do them in a half or even split them into 3. We've been asked for fixing details. So gable panels themselves, they're typically made from either 38 by 89 nailed or 47 by 97 plated. So these screw fixings is done for both timber thicknesses, and it's taken from, there's a part in EC5, it says that vertical joints between panels have got to be capable of transferring a value of 2.5 kilonewtons per metre run. So these fixing centres is based on providing that 2.5 kilonewtons per metre run. Limitations of use. When we first launched the gable restraint system, it was all based on maximum 3 stories for England and Wales and maximum 2 stories for Scotland. And this is, again, it's all taken from the requirements shown in the approved document A and the Scottish Building Standards. But we were asked the question by the NHBC saying, can we extend the use of it? So based on that, we went away and looked at everything and saying, how could we do this? So for these buildings, traditional restraint for buildings over 2 and 3 story, the horizontal restraint is reduced to 1.25 metre centres. So again, that strap's providing 8 kilonewtons of load. We've worked that back, and then to meet the requirements, say 5 stories for England and Wales and 4 stories for Scotland, we've recalculated the requirements. So it would mean that the PFS strap is getting installed at 1.25 metre centres. The RST3 strap is then getting installed at 800 mil centres, and the GRB goes down to 750 mil centres. And again, that is providing the same restraint requirement as the traditional restraint straps. So additional things that need to be considered. By following these details, we meet the requirements of the approved document A and the Scottish Building Standards, but the timber gable itself still needs to be designed. We haven't designed any of that timber gable. We've designed the connections for that timber gable. The timber gable The vertical studs have still got to be designed for vertical load coming down them, and also for wind pressure coming on these timber studs, so the studs aren't buckling. The wall tie spacing, as we see previously mentioned, again, we've put all the additional requirements to meet the NHBC, but the main spacing in the wall ties is the responsibility of the building designer. And the vertical restraint straps, we've put the specification and spacings for the vertical restraint straps, but the fixings of these vertical restraint straps into the blockwork is to be specified by the building designer. We don't know what blockwork has been used, so that's not our responsibility. So everything I've just been through should tell you a bit about the system, what we've done to develop the system, where the loads has come from, and we've got these additional resources available now. We've got an updated Gable Restraint System technical guide. We are in the process of updating the Cullen technical guide as well, which will include this. We've got an installation video, which we're going to show at the end of this. We've got a features and benefits video. If there's any technical questions, we've got our offsite technical support team. We've got our offsite technical portal, which all this additional resources are going to be held on the technical portal. So the webinar video will be available. The guides will be there. We've also got full CAD drawings. So all these CAD drawings that I've shown earlier, all these details, they will be available there as well in CAD format. I've provided these to, over the past few years, we've provided these to national house builders. Taylor Wimpey took my CAD drawings and dropped them into their details. So they are there, the resources, they can be used. And we've also got our offsite customer services team for contacting anybody about these. So I now believe that we're going to show the install video. Hopefully that showed you the detail within your new animation, and now I'm going to pass you back to Sam. No, I'm not. I am going to hand you over to Calvin, who is then going to go through Calvin from our Paslode team, who's then going to go through the positive placement nailer.
Thanks, Scott. Good afternoon, everyone. As mentioned, my name is Cullen Pretorius, one of the BDMs at Paslode. Paslode falls under the ITW group as well, if some of you aren't aware. But firstly, I'd like to start to thanks to the Cullen team for hosting this afternoon. Paslode actually started and was founded in 1935 and became the world's leading manufacturer of timber-to-timber fastening systems. We are the original nailer out in the market, and we continue to be the market leaders. Currently here in the UK, we offer 7 different types of tools, from your first fix nailers to your second fix and specialty tools. But today we're going to talk about our PPN, as Scott mentioned. It's our positive placement nailer. Firstly, looking at the, if you skip to the next slide. Firstly, if you have a look at the picture and the nose of the tool itself, it's completely different to your general first fix tool. We call this a self-locating probe, which is completely different, and there's a reason for that. So the purpose of this nose, some refer to it as a bit of a bird beak, but as soon as you place it into your metalwork, inside the holes, fire away, it gives you 100% accurate alignment to shoot and fire those nails into the metalwork. And that sort of makes it unique. The benefit of this product now, it's 6 times faster. So most builders on site will generally get the apprentice to sit there all day, hammering away with nails, and at the end of the day, they walk away with blue sore thumbs. So the whole idea of this is to completely remove that. We've changed a bit on the XI range. We moved away from the CI range to the XI, and we've made a bit of a different shape to it. We basically made it lighter. It's a lot more ergonomical. We've moved the battery around, so it's a lot more comfortable on site when the guys are firing. The battery as well, we've changed the performance into a better performing battery that allows up to 13,000 shots per battery charge. Furthermore, we've actually changed the gas itself to an XI series gas that allows you to fire away in temperatures of -15 to 49 degrees Celsius. Last but not least, once you've actually finished firing away those nails, to reload, basically quick release the magazine, reload, and the guys are back on site actually firing away. So as seen in the presentation, there's loads of applications on where we can actually use our twist nails as well as our PPN tool. Joist hangers, sole brackets, connector plates, truss clips, you name it. There's a vast amount of applications. And unfortunately, we're not going to show you a video this afternoon, but I am going to share a video in the link after this presentation for you guys to have a look at. We got our very own Paslode Danny that gives a broad explanation of the tool, actually demonstrates it quite a bit. And as Sam mentioned right in the beginning, we are giving a free tool away to one lucky winner. So best of luck, and short and sweet. If you've got any questions, I'll be here in the Q&A. Thanks, Sam. Thanks, Scott.
All right, thanks, Calvin, and thanks, Scott, as well. So what I'll do is we'll jump into the Q&A session. Scott, we've got a couple in the chat which I'll go through in a minute, but I'll open up with the first question for you. So what was the most challenging aspect during the system design in terms of health and safety benefits as well as system performance?
I think the most challenging thing was because the NHBC asked us not to just provide a bracket, we had to do the complete system. It was trying to understand where all the loads were and how we were going to try and take them through into the roof, into the actual roof diaphragm. We looked at different approaches, but it was making the complete system. So actually creating the bracket, the GRB, I'd say was probably the easy part. Then understanding everything else, where all the other loads were going, and working all these other connections, it was in making it into a complete system was probably the biggest challenge there, the most complicated part of it.
All right, thanks, Scott. So we've got a couple of questions in the Q&A box, which I'll start with. So we've got Richard Jarvis. So he's asking, the RST3 is a 1.2 metre centres. What's the max difference from the eaves to the first/last RST strap?
From the eaves, so you're talking about from the actual, for the corner of the wall, the maximum distance is your 1.2. You go and take, same for your gable restraint bracket. You're taking that corner bit has already been restrained. The corner of the building is already providing restraint. So your maximum distance is the 1.2 from the end of the building. And it's the same when installing the GRB at the 1200 centres. Again, you can't go more than that 1.2 away.
Okay. Richard, do you need any more information on that if you want to unmute yourself? Or?
No, that's good. Is there a clash then if they're both at 1200 off the eaves? Is there a clash between the GRB and the RST?
No, because they'll be sitting at different levels, so you'd never clash with them.
Okay. Tap.
All right, thanks, Richard. Bradley Atwood, so we've got more of a sort of note in terms of improvement for the video, so we'll take that on board and review that internally as a team. So thanks for that feedback based on the video. I'll move to the next question, which is Martin Cox, who is asking if the wall ties must be Cullen spec only.
Martin, of course they have to be. The wall ties, as we're saying, the wall ties is responsibility of the building designer. For the spaces and that, I've done the spacings I've shown for the wall ties is to meet the requirements of the NHBC. Now, I do know at the moment we can't do the 125 mil or 150 mil wide cavities, so we can't provide a Cullen wall tie for that. But that comes back to it being the responsibility of the building designer. We've shown the gable restraint bracket system as the GRB, the RST3, the holding down strap. That is the part that has been all approved by the NHBC. I've actually sent the wall ties detail and everything to the NHBC, and they're happy with what we've sent them as well. But the wall ties itself does come back to being the responsibility of the building designer.
Thanks, Scott.
Thanks, Scott. Okay, Scott, and then we've got one more in the Q&A chat before we open up the floor. So this is from David Wilson, and his question is, what's the recommendations for when you have less than 3 number of trusses to fix the straps to? For example, a front projection area with only 1 truss, a girder truss.
Watch the space, because that is something that we have discussed on your last TRA technical committee meeting. It's been raised by others. It is an action against myself to go look at. So at the moment, we're looking at how you go and do it. The gable itself, yeah, you could go and do everything with the gable restraint bracket, but then your strap, as you said, you've not got the 3 trusses to attach to. So where does that load get taken to? If you could have actually, potentially you could just have a girder truss and nothing behind it, or 1 truss. So these projecting gables has been looked at, and it is on my to-do list. So that'll be, watch the space. We'll have something on that shortly, hopefully.
Okay, we've got another 2 that's came through the Q&A box, but is anyone, before I go dive into them, I just want to make sure everyone's getting an opportunity here. Has anyone got any open questions that they want to ask at the moment? Just unmute and let us know. I've got 3 in the chat, which I can go back to if not.
Got one I'd like to ask. If that's all right, Sam, can you hear me?
Yeah, go for it.
Yeah, so what does NHBC acceptance actually entail? And then what's been the greatest challenge in obtaining it?
The challenge, we'll start with that, was the NHBC originally, when we first started talking to them, they wanted us to go and provide more. It's like they wanted that whole system. So it was trying to get them to understand explain to them where all these loadings were and how we were what loads we were taking and taking the equivalent, and we had to tie everything back to that approved document A and the equivalent of the restraint straps. So the NHBC, the detail we have shown with the GRB, the RST trees, the vertical holding or VRS straps and the PFS straps, all that got submitted to the NHBC with all our calculations showing the nailing for the wall plate, the lot, their testing on the RST strap attached to the vertical timber stud. That was all passed to the NHBC, and although the NHBC do not approve things, they basically said that meets their requirements, meets their technical requirements, and if you follow this, then you're meeting their requirements and you're meeting the requirements of approved document A. They will not query it. Well, depending on who the inspector is, but they shouldn't query it. That should be, and I've got a letter to that effect. So originally, when we first launched this, we got queries, we got questions back, but we've not had any name for a while. This has all been circulated through the NHBC. They should all be pretty much happy with it.
Right, thanks, Scott. Have we got any more questions open to the floor? I've got a couple in the chat, if not. Okay, I'll go back to the chat at the moment. Okay, so we've got a question from Paula Gilbert Hawthorne. So with regards to the Gable Restraint System, what advice would you give to those of us looking to transition or implement the Gable Restraint System?
Biggest piece of advice is, well, use the CAD details we've shown. Send them to house builders if they want to go and they start including them in the documentation. That great, but the biggest piece of advice would be to make sure the gable restraint brackets, the GRB itself, is on site prior to the trusses going up. It's got to be on site when that wall plate's been bedded in, which is getting done before the trusses are erected.
Okay. Cheers, Scott. Okay, so we've got another one from Tom Jones. So does the blockwork timber between the truss and panel need to be continuous of the bottom cord, or just where the straps are?
Just locally. Sorry, on you go.
Sorry. So second part of this question, guys, says, assume that the details does not allow large spacing away from the wall, i.e. larger than 50 millimeters.
There's usually that first truss is kept about 50 mil away from the wall. It's no timber frame where we go and sit the timber frame, the typical set the first truss 600 mil away. It's basically brick and block, so you're needing that first truss sort of there to catch your plasterboard and everything. That 50 mil, it doesn't have to be continuous. It could be locally where it could be local blocking pieces where the RST3 strap and the the longitudinal bracing on your trusses is. It's just a blocking piece between the two.
All right. Thanks, Scott. Then we've got another question from Andrew McShane. So you mentioned Taylor Wimpey. Can you say which other house builders you are talking to and are interested in using the system?
At the time, Taylor Wimpey, we'd done a lot of development work with Taylor Wimpey, but we also site trialed this and done a lot of the site trials and everything with Barrett's. So Taylor Wimpey and Barrett's are already using this. To be honest, I am not sure of what other builders are using this at the moment. That is I know these two because I was personally involved in dealing with them. But there are others out there, and the idea we're having this webinar and this additional video and information is we are going to start targeting these house builders and also hoping it allowing you to go and target these house builders as well.
Yeah, right. Cheers, Scott. Okay, and it looks like the last question, which is from the ST group. Can you still use an RST at rafter level?
Yes, you can. You can, but at rafter level, you would have to make sure you're, instead of attaching to like the longitudinal bracing, you would have to make, because you'd have to go and put blocking pieces between the truss to make sure that because it's got a 90-degree bend in it and you're attaching to the vertical stud. So you attach it to the vertical stud, same as we are at the bottom, but a lot as it's coming back in amongst the trusses, you've got to make sure that blocking piece is sitting vertical, so you could attach into that as well. You could still use the RST3 at rafter level, but you wouldn't use it at it's no at 2 meter centers. If you're using the RST3 at rafter level, it's at the 1200 centers, the same as what we've specified for the RST3 along the bottom. The RST3 attached to the timber provides you with a value. The PFS hooked over provides you with a much higher value, and that's why the centers are different.
All right, cool. Cheers, Scott. So it looks like that's all the questions in the Q&A chat box. Unless anyone's got any further questions, we'll move on.
Scott, I just got one. It's Martin.
As long as it's simple.
Yeah, okay. It will be for me. Are you looking at anything to do with thermocell sheathing, or when we sheathe the inside face of a gable panel to meet the NHBC requirements?
Is this when you're being close to the boundary, or you're above a certain height for the fire requirements from?
Yep.
That'll be from inside out then, eh?
Yeah, that's it. So you can't get your RSTs in at the bottom.
Yeah. I could look at it, to be honest. It's just going to have to go and be a face fix through the thermocell. I'd probably end up doing something using the PFS, and so you could sort of screw it into the face of the stud. It would be an easy fix. So it's no on my to-do list, but it could be easily done.
Good. Thank you.
Yeah, Martin, we can follow up on that one. Thanks for bringing that forward. Scott, one last one in the chat before we close out the Q&A session. So, question from David Wilson. Does the block workpiece need to be the same depth as truss bottom cord?
Sorry, go and say that again.
Does the block workpiece need to be the same depth as a truss bottom cord?
You mean the blocking piece between the blocking between the truss and the gable panel? I would say yes, make it the same depth as the truss bottom cord. All
right, okay. Okay, thanks for all the questions that have came in. Really appreciate the engagement from the group. We'll close out the Q&A session there and move on to the prize draw. I just wanted to thank everyone for giving up their time to join today's session. We really appreciate it. I also want to extend my thanks to all of our customers. You guys provided a lot of feedback through our customer-backed innovation process, and that has shaped the efforts of not only this webinar, but the GRB campaign that we've been working on in the last couple of months. And then lastly, I would also like to thank the ITW team for their hard work in creating the content that was required as well. Like I said in the Q&A session, if you have any questions or you need additional information, we definitely want to hear from you. So you can reach out to one of the commercial team members or customer services team members that you can see here. And we have two services there as well through our customer services and technical services contacts. So feel free to reach out at any point. Also, as I mentioned a second ago, we couldn't achieve this without your valuable input. So at Cullen, we're always committed to listening, learning, improving continuously. And to help us in this effort, we've created a short feedback form, which you can access via the QR code that's on the screen at the moment. Don't worry if you don't have time to do it at the moment. Andrea will be sending a summary follow-up email on the back of this webinar, which will also have the details to sign up and do the feedback form. So if you have a spare couple of minutes, we'd really appreciate that. I think it's 6 questions, and I think one of them is what is your name, so even shorter. That concludes today's session. Have a great day, everyone, and again, thanks for your time and cheers for joining.